Good morning, students. Today we are going to discuss the topic of solid state. First of all, we are going to discuss what is meant by crystalline solid and amorphous solid. So, crystalline solids are also known as true solids, in which various atoms, ions, or a molecule are arranged in definite order, that is geometrical pattern, throughout the entire three-dimensional network of solid. Such solids are basically known as crystalline solid. Example of crystalline solids are sodium chloride, sulfur, sugar, etc. Now, what are the characteristics of crystalline solid? They have sharp melting point. They have definite heat of fusion. They are generally incompressible and rigid. They are bound within the well-defined planes. They are anisotropic. Now, what is the meaning of anisotropic? The anisotropic means that is the magnitude of physical property like electrical, thermal conductivity, mechanical strength, and refractive index are different in different directions. So, true solids have anisotropic nature. Now, for example, in silver iodide, the coefficient of thermal expansion is positive in one direction while it is negative in other direction. So, in AB direction, coefficient of thermal expansion for silver iodide is positive, then in this direction it should be negative, because silver iodide is crystalline solid. That's why it is anisotropic in nature. Now, what is the meaning of amorphous solid? Solid in which atoms, molecule, or ion constituting the solid do not have definite geometrical form are called as amorphous solid. Example: rubber, plastics, glass. Now, what are the characteristics of amorphous solid? Amorphous solids melts gradually over a long range of temperature. It simply means that they do not have sharp melting point. That's why they do not have definite heat of fusion. They are isotropic. That is, the magnitude of physical property like electrical and thermal conductivity are same in all the direction. Generally, characteristic of true solid and amorphous solid is asked in exam. Now, we are going to see some important definition related to your solid state. The first definition, first term is unit cell. Unit cell is defined as the smallest repeating unit in a space lattice, which when repeated again and again in different direction to give crystal. So just see in this diagram, this smallest diagram is repeated again and again in your this big three-dimensional network. That's why it is known as unit cell, and it is the structure of crystal lattice. So, extension of unit cell in three dimension, it is generally known as crystal lattice or space lattice. So, it is defined as three-dimensional regular arrangement of atom, ions or ions, showing how these unit particles are located at different sides. Now we are going to see what is meant by lattice point or lattice side. These are defined as position occupied by the particle of the crystal. So just see in this diagram, this unit cell, there are 8 dots are drawn. So this 8 dot basically it is known as lattice point. Now what is meant by interfacial angle? It is defined as the angle between two intersecting faces of crystal. So just see, here are alpha, beta, gamma angles are shown. So these angles are basically known as interfacial angles because just see A, B, C, D, it is the one plane, while D, C, E, F, let this point be F, it is another plane. So angle between the planes is known as interfacial angles. Now what is phase? The plane surface of crystals are called as its phases. So just see in this unit cell A, B, C, D, it is known as face of the crystal. Also D, C, E, F is also one of the face. So always remember, in a cubic structure there are always 1, this is second 2, this is 3, this is 4, this side face is 5th and that side face is 6. So just see, this is the cube. In this cube, this is the first face of the cube, this is second face, this is third face of the cube, this is fourth face, this is fifth face, and there is sixth face which is below. So cube always have 6 face. Now we are going to see some law of crystallography. Now what is mean by crystallography? First, the branch of science which deals with the study of geometry, structures and property of crystal is called as crystallography. 3 basic law of crystallography is law of constancy of interfacial angles, also known as Steno's law. Law of rationality of indices, also known as Whose law. And third one is law of constancy of symmetry. These 3 laws are very important. Generally, out of 3, 1 law is always asked in the exam. Now we are going to see law of constancy of interfacial angle, that is Steno's law. This law states that under the similar condition, all the crystal of same substance have same interfacial angle in respect of their size and shape. The crystal of same substance may have different size and shape depending upon the condition of crystallization and rate of cooling, but all the crystal of same substance have constant interfacial angle. So just see, here are some crystal structure of Si2 is drawn. So this all structure, we see that structure A is somewhat different from your structure B. Structure B is somewhat different of structure C, but they are all crystal of Si O2, and according to Steno's law, the interfacial angle are always equal. So basically this angle and this angle value is always equal. Now we are going to see law of rationality of indices. So this law can be stated as the intercept made by any plane on crystallographic axes are simple whole number. It is important. Are simple whole number multiples of the intercept made by the units. So just see in this diagram. Suppose ABC, that is this ABC is a unit plane having intercept on the axis AB and C respectively. Let L, M and N, so this is L, this is M and this is N, cuts the three axes by intercept LMN. Then coefficient LMN are called as Wien's indices of the crystal. These indices are integral or whole number or fraction or infinity. Now according to Wien's law, then A is to B is to C is equal to LA is to MB is to NC. Now we are going to see third law, that is law of constancy of symmetry. This law can be stated as all the crystals of same substance have same elements of symmetry. It is important. Now students should note that NaCl possesses 23 elements of symmetry. So now we are going to see what is the meaning of elements of symmetry. So symmetry in crystal may be due to plane, a line or a point. An imaginary plane, line or a point in a crystal through which reflection or rotation gives identical shape are called as element of symmetry. There are three elements of symmetry associated with crystal. First is center of symmetry, second one is axis of symmetry, third one is plane of symmetry. So now we are going to see what is the meaning of center of symmetry. It is defined as an imaginary point in the body of the crystal such that any line drawn through it intersect the opposite face at equal distance in both directions. There is only one center of symmetry in the crystal. Now just see, this is the crystal structure dot, and at the center of crystal there is an imaginary point from which all the particles, for example, here is one particle, here is one particle, here is one, here one, here one, here one, here one, here one. Since it is the cubic structure, there are 8 particles which are present at 8 corners. So from this point, all opposite particles are equidistant. So just see, if we take this cube and there is one imaginary point at the center of this cube from which every opposite point is equidistant, that imaginary point is simply known as center of symmetry. Now we are going to see plane of symmetry. It is an imaginary plane passing through the crystal and which divides the crystal into two symmetrical parts such that each part is exact mirror image of each other. Now just see, this is the cubic structure, and if we cut this cube from like this, if I draw an imaginary plane which is passing through this, and if so that plane cuts this cube into two equal half. Your right hand side, that side of half is exactly equal to your this side of half. We can draw also other plane from like this. If a imaginary plane cut like this, so your this half is exactly equal to this half. You can draw a plane like this also. So this half is also equal to that side portion. So what is plane of symmetry? It is an imaginary plane which cuts the crystal structure into two equal half. Now we are going to see axis of symmetry. What is axis of symmetry? An imaginary line passing through a crystal about which a crystal when rotated through 360 give exactly same appearance more than once. It is called axis of symmetry. So just see, in this parallelogram, A, B, C, D points are present. Now if I rotate this parallelogram by 90 degree, then A comes at your position of B. So again if we rotate this parallelogram, then A comes at the position of C. If again by 90 degree we rotate that parallelogram, then A comes at your position of D, and then again if you rotate that, then it is A comes on its original position. So that's why 360 divided by 90, so we got 4. So this geometry have fourfold axis of symmetry. Now just see, in this hexagonal structure, point A, B, C, D, E, F, if we rotate, so how many rotation is required to come A to again at its original position? So it simply required 6 rotation. So in first rotation, A comes at your position of B. In second rotation, A comes at position of C. In third rotation, A comes at position of D. At fourth rotation, A comes on your position of E. At fifth rotation, A comes on position of A, and at sixth rotation A comes on its original position. So this hexagonal ring have 6-fold of symmetry, 6-fold axis of symmetry. So in our next class we are going to discuss a very important topic, that is Miller indices. This topic is definitely asked in a exam. Thank you very much.